All right. Good morning, everybody. Thank you for joining us. This is the DataVault, a comprehensive project-focused approach to research data management. Our presenters today are Derek Cooper from the Mortgage Institute for Research and M. Kraft with the Wisconsin Institute for Discovery. Derek and M, thank you very much for joining us.
Thanks a lot.
Thank you.
Yeah, you're gonna push the button.
I'll get you started and
All right.
tilt it this way.
So, as we were having a little discussion beforehand here, I started before the building opened in 2010. It opened in December of 2010. I think we had, I don't know, maybe about less than 150 people that we started with, I think, when we first started out that first year. So, but one of the big needs right away was disk space. That's kind of a norm in the research environment. I mean, obviously everybody needs disk space of some kind, but these guys are a little bit on the greedy side when it comes to disk space, because we're in the petabytes now of disk space that we're using here at the Discovery building. So we started doing research. The main distributed file system, we wanted something that was easy to build and also easy to expand. And so we started looking at distributed file systems. IceCube was using Lustre. Red Hat had just recently purchased Gluster. And so we looked at them both. I was able to build a Gluster cluster in my office on VMs in like half an hour. I thought, boy, this sounds pretty good. And so we kind of thought Red Hat would be a good bet for this open source project. And it turned out to be okay. But that was our goal. So we went with Gluster as a building, and we put up our first couple hundred terabytes of disk space of Gluster, and I think that we put that up in 2011. Yeah, sure. So one of the things that we were tasked with was trying to get metadata. So Miron Livni has years of experience, decades of experience in working with researchers. He said, we need to collect some metadata to manage the data. That was my responsibility. And of course, at that time, I had a lot of responsibility. And I just, I passed out the forms. I asked people to fill them out. And I didn't get one single PI to fill out the paperwork. And so that was a massive fail on my part. And then so we put in some quotas to try and manage the data, but it didn't actually work very well. We had people, especially as people could start a CHTC job that was connected to our DataVault. Not only could they bring the whole thing down to its knees performance-wise, but they could also fill an entire volume. I think I remember one job created like 100 million files, just in one group of directories. So that became a little problematic. And so because we didn't know who all owned all the data, it was just departments, and there was no real management at all of folders that was required. Yeah, it became pretty impossible to clean up. We had to clean up, and it just became a very egregious task. That's about the only way I can describe it. One of the other big problems was that researchers were putting files in multiple locations on the disk. And so eventually we got some software to help us try and identify that, but it was still really a problem. So we started looking at other solutions. The first one that we came about was really a great solution. It was called Galaxy. I still think it's a great concept. We tried to implement it. It was not really an enterprise-ready software. If you had a single department and you weren't super concerned about security within that department, it would have worked great for you. It tracked the files, the metadata, the software versions. I was totally enamored with this software. So we got it up in one of our departments, and they actually ran it for a number of years in Jamie Thompson's lab. But we also tried to implement it at the enterprise level with CHTC, and for some reason, when we would run the CHTC jobs out of Galaxy, it wanted to run as root, and then we would have access to everybody's data that was on the server. And so we couldn't do that. And so that was the end of Galaxy for our big solution. So from there, so here we are 6 years later, and we're running out of disk space again, once again. And so we put our heads together, and WID decided to break off from our shared Gluster cluster. And we worked together to try and implement something that would help us manage the data lifecycle. And so they bought a bunch of Dell storage servers. An additional server was also added for home directories. And we used a Redmine ticketing system and started tracking all the metadata by project for the most part. Em will get into the specifics of this a little bit later when she talks about how we tried to manage all of the projects, everything by project, but we weren't always successful. And so anyways, it allowed us to track authorized users. We have it set up so that we can scrape all the new data, all the new projects that are out there, and we use scripts to automatically provision our servers for ACLs and quotas and all of that kind of stuff. Users, it's actually really neat system. Really saves our guys a lot of time working with the servers and puts the data out there so that we can track it over the life cycle. We started looking at, and so actually just going back just a second. So the WID DataVault was originally, they were just Linux servers running ZFS or XFS. Yeah, they were running XFS file systems. They weren't distributed file system when we put up this original one. In about 2020 or 2021, we put up a backup cluster for ourselves. We wanted to try out Ceph, and Ceph had been started to be used from a whole bunch of other campus environments, including CHTC and Space Sciences, and so we got used to using Ceph as backup. Finally, in 2023, we were able to talk our management into building our own DataVault and using the DataVault system that WID had been using for about 6 years. And I thought it was really great. You know, I tried to sell it for 6 years after we put it in place, but it just took a little longer on the mortgage side. We put somebody in charge of working with the PIs. Andrew Meyer became our data evangelist. for the Mortgage Data Vault. And so we were running that on Ceph. And we use Supermicro hardware for ours, just because we just couldn't get Dell to give us as good a pricing. It's been really solid for us, a lot more solid actually than Gluster was. And so we've been really happy running Ceph. Let me see, was there anything else? Did you add into your slides that the new Data Vault is running Ceph? All right, I'll let you speak to that then. All right, over to M.
Hi, everybody. My name is Em. The last part of it is going to sort of go through the life cycle of DataVault projects. The terms specifically are PI project data to talk about like the data of a research project, the metadata of everything about the project, and project completion is when we think the data is no longer required and UW closeout has occurred. That'll come up a couple of times. So when a PI wants to create a DataVault project, they use our ticket system. Our ticket system is currently Redmine, but it could really be any ticket system. The goal is to get the information about who the PI is, what the PI name of the project is, how big it is, who needs access, and a bunch of other little information about the project. Sometimes it's if there's a specific grant fund for it. Sometimes they know a closeout date. Sometimes it's things like whether or not the project needs to be back up. And by default, all of our projects get backed up. And then once the information about a new project comes in, the server team takes that and initializes the project. They have a lot of it managed with scripts, and the software that we use specifically is in the parentheses, but the concept of grouping things by project is sort of, you can use whatever software you want. We use Ceph for the backend data storage, Python scripts to initialize things like quota and user permissions and groups. And when it was XFS, we used FSS quota. Now that's Ceph, we use however you pronounce that. The backups are all handled by our snapshot, which is sort of a wrapper to rsync. And once the server team initializes the project, they let the PI know that it is ready, and then it's available for use. What the PI sees when they create the project is this page. And we really try to make it as straightforward and easy as possible to create a new project. They fill this information out, they say how big it needs to be, who needs to access it, and that's it. After it's available, they're able to connect to it. Yeah.
We have a question. Do you wanna speak to that real quick?
So the WID Data Vault is available for WID PIs. It is currently available to people with DiscoverIT accounts from within the Discovery network. And so we do not have any licensed or protected data on the Data Vault currently. So when they access the data, if they are on a supported compute server, it is connected via either NFS or the kernel drive. If they are not on a supported DiscoverIT server, if they have instruments or laptops, they can connect to it via SMB as the user level permission. And all of the Data Vault projects are mounted via Globus. And so they're able to use Globus to transfer a lot of data in, transfer a lot of data out, do that sort of thing. But everybody who connects to the data does need a DiscoverIT account. Let's see, when people get added as new users to WID, that new onboarding process all sort of gives them access to the projects that they need. Whenever a PI requests a new person in their lab, they say they need access to this data, this data, this data. And then at the end of every semester, we do audits and make sure that when people leave, they lose their access to the data and all of the other IT resources. For project management, we have graphs that show the usage of the volume over time. We have Discover data that will show you an actual breakdown of, you have this many files owned by these people that are 2 years old and in this location, which has been essential for data cleanup when you have things that are 20 terabyte volumes and you have no idea where anything is. We also get notifications through Isinga if the usage goes up too high or if there are too many inodes. It is definitely possible for Condor jobs to create literally millions of empty files that the users couldn't find. So a combination of Isinga notifying that it happened and Discover data to find it has been very useful. One of the harder things of having all the DataVault projects in Unix is that people are accessing these files via Windows and Macs, and sometimes they don't know Unix file systems. So we do have each DataVault project as a Unix file system with group permissions set up to be sticky bit to that group, but they still have to set their UMask, and we do help them trim out their files as necessary to make sure everybody in the project has access. And at the end of a project, hopefully, we see that the project is over, nobody needs the data anymore. We put all of that data over to the DoIT archive, and then we wait for 7 years, and then we can delete all the old data in the project. The DataVault has been around for 7 years as of this fall, so this fall will be the first time we start to delete old data. But it'll be a new process, and we'll double check with each PI at each level. This project is done. Can it be deleted? So we'll see. But for the projects in general, most DataVault projects are like the PI and then the project name. So if you have a project that is looking at any kind of cell, it could be like PI name dash cell type, that is their project. And when people come into the project, they get access to it. When they leave the project, they lose access to it. Sometimes PIs will have projects that are just for all of their raw data. And this is data that isn't expected to expire after 7 years or at a project closeout. It is data that they will use for the lifespan of their lab. And when somebody joins the lab, they get access to their raw data. We also have a WID software folder. So software that we manage and compile for people to use on the cluster is available in a project. But then there's also some people who just like shared volumes of everybody in my lab gets access to it. We'll create a group that has just the PI and the student in it, and they just share between the PI and the student, not project-wide, and that works too. This does not replace a home directory. WID has home directories for all WIDites. We limit it down pretty hard to try to enforce people putting research data in research project folders. Some machines still have local storage. People use removable storage to get things on and off equipment. CHCC storage is incredibly useful for using their devices. Research storage, campus globus or campus licensed cloud storage, it's all still available. So yeah, that's sort of the quick rundown of what the DataVault is and what projects are and the lifespan of it. I think that's the last slide. So do we have any questions? So the question of, are we backing up the data? So right now, WID has a Ceph cluster, it has like 10 machines in it. And at the moment, we're still just using our backup tools to go to our old cluster, or our old storage. So when we had a whole bunch of Dell disks, everything was stored across there. Now that we're on the Ceph cluster, we didn't actually have the funding to completely replace all the backups. So right now we're not doing anything clever. We're just backing up the entire Ceph cluster to our old hardware. That was our production cluster or server. But at some point we will have a backup Ceph cluster as well and be able to do that.
Yeah, and Mortgage does have a backup. We do have a backup. So that was our first one, actually before our production Ceph cluster. So Any other questions?
You can put questions either in chat, or if you want to come off mute, please raise your hand virtually first, and we can do that as well. Pausing here for anybody that's typing in is slow.
So what I can say is that this does have a bit of a lead time when we get new PIs to sort of understand how we try to organize the data. They're used to environments where I am new PI, give me 20 terabytes and I will use it. And trying to sort of help guide into, but if you do it project-based, we have sort of this compartmentalization that helps, like, the people in that project who need access to it get it, the people who don't need access to it don't. When you bring new people on board, they can just see what folders they have access to, so you don't have to help teach them where it is. It's just, here's all the data for all the projects that you're part of. And when a project ends, it's easier to clean up and be done.
This will be probably more comment than question for you, but since you say you're at the 7-year mark and you're going to start looking at doing some data cleanups, I can say that's something that we're actively looking at in the School of Education as well. And from talking with other colleagues across campus, I think this is something that is either not consistently done, or people aren't a little sure on implementation. So I think as you go through this, if I can put a nudge for next year, could be an interesting presentation for next year's IT Professionals Conference of how did that 7-year cleanup go? How were the communications? What were the pitfalls, and what would you have done differently?
Well, and part of, like, when we transferred all of our data from the old systems, and they were in a couple different places and in Gloucester and all that, into the data vault, like, they already knew that there was some data at that time that they didn't need live. So that's the big chunk of this fall, everything that they sent off to the archive and literally haven't touched this whole time. And so just throughout the semester, throughout the years, there will be sometimes they designate, well, I really don't need this chunk anymore, and we'll send it to the archive and put the date stamp on. So this first batch will be all the stuff that 7 years ago, when we started the data vault, they said, yeah, we really don't need this, but we don't know what it is. So do you have a rough idea of percentage of data storage options used? So in general, because the local storage on the servers isn't backed up and our laptops aren't backed up, hopefully it doesn't get used that much. And so the vast majority of our research data at WID is stored on the data vault. Right now we have, I don't remember, 300 terabytes, something like that.
Yeah, 300 to 400.
And so it's just a lot of data. For the PIs that have left the university or retired, you can tell to develop their data. Yes, and sort of. So we definitely hold on to the data for 7 years, but we also work with them to give them the package of it on their way out. It's happened a couple of times so far. And so since we, have, these are their data vault projects, we will give it to them on 2 hard drives, and then also send it to the archive and let it said it's 7 years. How do we communicate with researchers on which data storage type is the most appropriate for their needs? So that kind of also breaks down to which data vault project type they use. Some of our PIs don't need a lot of data. Some of them need, maybe a terabyte. And for those cases, they may be more wanting to use like the research drive, or not as much the Google Drive anymore. But they're the ones who fit more into sort of like the shared system, where they just want one big project and they'll store things on there and manage them. And when people get added to their lab, they just get added. It's when people need to access data, a lot of data, anything more than, say, like 5 terabytes, which is over 75% of our PIs. But from a lot of like locations, from a lot of different places, that the data vault has been really helpful. Also, we have a local compute cluster like in WID that can access the data directly. So like one of our PIs has her own compute resources, about 12 machines right now. And so they both run like local jobs that people are computing against the data, but also submitting to a Condor pool that will run from that data. And yes, somebody put out a useful link to be able to analyze the campus data options.
Yeah, there was also a question, how do the research groups use the raw data folders? Do they routinely put data from instruments there, for example? That's from, at least on the mortgage side, that's a big yes.
So the hope, the goal, the training is for when you mark up that this is your raw data storage, you use it as sort of a deposit. You don't do your data analysis there. You don't edit things. You take it from the instrument or from the surveys or from downloads or however it is you gather the data, and you put it in that folder. And then you have a separate project folder where you would be doing the analysis of the data, the write-ups of it, the software of it, and so on. So the goal of the raw storage project is raw data. But yeah. Yep.
If we have any other questions, we have time for one, maybe two more. But we are drawing close to the end of our time.
While we're waiting here, I just wanted to go back and put a plug in for this piece of software that that Em had in her portion of the presentation called DiscoverIT. This is written by a really neat guy that really wants to support research, and he originally we used his product called Clarity, and then he probably sold it to Dell for a lot of money. I know he sold it to Dell, but probably for a lot of money. And then after his NDA was up, a couple of years later, all of a sudden he had a new version of this file management software. But this allows PIs to go in and look at their files, their directories, and they can do a lot of management through a graphical interface. And it's really a neat piece of software. So.
Yeah, I would say in general, the thing that has helped WID manage our data the most is by trying to compartmentalize. On campus, we have a lot of problems with silos and compartments and things that are broken up too much. But for the research data, it has been essential to try to break it into projects so that when it's done, it can be removed and dealt with. And
Yeah, mortgage, just to say, mortgage still has every piece of data from the last 13 and a half years. So we'll be looking forward to the time when we can actually start archiving stuff and getting rid of it permanently.
All right, so we are basically about at time here. And with that silo comment, I think resonating with a lot of people, we'll call it here. I want to say a very big thank you to Em and Derek for this fascinating conversation and presentation today. And also a thank you to Laurel Bellman, who has been doing all of our tech work on the background and keeping this running smoothly. Thank you again for presenting. And I hope everybody has a great rest of your virtual conference.
Thanks, everyone.